Okay, in this video I'm going to go through the 7.3, 7.4 review activity. So the first question talks about the similar triangles that result when you drop this altitude. Okay, so this is an altitude in the middle of the triangle. So when you drop that altitude, you get three similar triangles. Here's one, here's two, and then the whole big triangle was three. Okay? All right, so let me get rid of all that stuff. Okay, so the first thing I want to tell you is I left this spot about doing your work because I think it's easier to compare the big triangle. So here is, I'm going to call it BAC. I'm going to start with the right angle. I think that's a good way to start most of these types of problems. So that triangle is similar to one of the small triangles. Let's go with this triangle first. Okay, so where is the right angle in the top small triangle? Okay, so you should be saying it's at D. So therefore, since we're starting with the right angle first, start with D. Okay, so then, what angle does the big triangle, so here is your big triangle, okay, big guy, have in common with this little guy? And you should be saying the angle A is common to both. Look where A is. A is in the second position, so put A second. What's the third letter in that top triangle? You should be saying B. And there you have it. Okay, so then you can put DAB on this line right here. Now, I'm going to erase what I have on this big triangle because we're going to do the comparison between the big triangle and the other little triangle. All right, so let me even change color to do that. Okay, so here's the other little triangle now. So we're looking at the big triangle in red, okay, and this small triangle. So looking at those, what do I know? Okay, I'm going to list the big triangle in the same order that I listed it before. I started out with the right angle, start out with the right angle here. So I'm going to start out with letter D. All right, then ask yourself, which angle does the big triangle and the small bottom triangle have in common? And the angle they have in common is this C angle. Do you see how that C is a part of both the small triangle on the bottom and the big triangle? So look and see where your C is located in your first big triangle and put your C in the same position. So it's in the last spot. Then what's the other letter in this triangle? And you should be saying B. So your expression is complete now, and you can bring it up to the top, and I can say DBC. So that's what you should be getting when you write a similarity statement. And this is your best approach. Okay, let's go on to geometric means. Okay, so here we have 4 questions that deal with geometric means. So one comment I'll make first, and I guess I'll do it down here. When you have a big triangle, so we'll just do it like this. When you have a big triangle, and it's a right triangle, and you draw an altitude, you have geometric means that occur. So the geometric means are going to be, and I'll change color. So this is a leg. It's a geometric mean. Here is the altitude. Oops. It's a geometric mean. And here is the other leg. It's a geometric mean. So then I'm going to put letters on the hypotenuse. Okay, so I'll call this A, B, and then we'll call the whole length C. Okay, so I'm going to set up 3 equations. Okay, when I look at the first leg, leg X, it is a geometric mean. Therefore, it goes 2 places, low and high. It's the geometric mean between the piece of the hypotenuse closest to it and the entire hypotenuse. So that would be the setup for that. Then let's look at the altitude. The altitude is also a geometric mean. So it goes in the geometric mean spot. it's a geometric mean between each little piece of the hypotenuse. And lastly, that third leg also functions as a geometric mean. Remember, geometric means is just another kind of average. Okay, so I put the z in the geometric mean spot, and it's a geometric mean between the side of the hypotenuse closest to it and the entire hypotenuse. So this little problem down here, this gives you an overview of all our work with geometric means. So let's now do applications of that setup. So looking at problem number 1, or actually guess number 2, what do I have? I have an altitude. The 48 is an altitude. So that means the 48 is a geometric mean between the 36 and the other side of the hypotenuse. So you would say, doing cross products, 36 times x equals 48 squared. So if you divide both sides by 36, 48 squared over 36 gets you your x. And in this case, what are you getting your x to be? So you should put this in your calculator. And you should have been getting, let me just look at my answer key here. You should have been getting x to be 64. So x should be 64. Okay, and I just added this new. I listed the answers down here, so that was the 64. Okay, let's change colors and we'll do the next problem. This is also an altitude problem. So the altitude is the geometric mean, so you put it in the geometric mean spot between each piece of the hypotenuse. So 12 squared equals 16 times x. So x is going to equal 12 squared, which is 144, divided by 16. So we're getting x to be 9. Okay, so x was 64 here, and x is 9 here. Let's go on to the next problem, number 4. So number 4 is also an altitude. So put the 48 in the geometric mean spot, and it's the geometric mean between each piece of the hypotenuse. So when I do cross products, I get 48 squared equals 64 times x. Okay, so 48 squared divided by 64 gives me my x, and that is 36. Okay, we have one more, and it's not an altitude. This last one is a leg. So that leg also functions as a geometric mean. So we have to be careful here. Put the 15 where the geometric mean goes, but what kind of geometric mean is it? What are the two numbers that you have to consider? Well, you have to consider the piece of the hypotenuse closest to the 15, so that's 9, and the entire hypotenuse, which is x. So we get 15 squared equals 9x. Divide both sides by 9, and you should be getting x, I'll come down here, equals 25. Okay, put that in your calculator, and that's what you should get, and that's my fourth answer down here. Okay, so that geometric mean, looking at triangles, should be clearer to you now. So go back and listen to this again if you have questions. Okay, I did 3 altitudes and 1 leg, but that should give you a good idea how to handle these problems. Okay, I'm going to go on to the next page. Okay, here I'm also asking about geometric means. Now, geometric means don't have to be tied to a triangle, but you're still going to operate the same way. You're always going to have fraction equal fraction, and then you're always going to do cross products. So if I say, what is the geometric mean? I'm looking for it. Let's make that x of 8 and 2. So those are the two numbers. X has to go in the geometric mean spot, because that's what we're looking for, and 8 and 2 go in the other two spots. So x squared equals 16. So therefore x is going to equal 4. Okay, I also added this little box. Okay, so x is 4 there. Let's read the next one. So the next one says, what is the geometric mean? Okay, so we're looking for it. So that's going to be my x of 5 and 7. So get your fractions again and put your x in the geometric mean spot, and you have your 5 and your 7. So x squared equals 35, and therefore x is going to equal radical 35. Okay, now you should try to reduce this. So let's see what happens when I try. I get 7 times 5 as the factors. Those are both prime. I can't do anything else, so there's no need to do this step. And my final answer is x is radical 35. And that's right here. Okay, go on to one more. Okay, here we say that what is the geometric mean? So again, that's our x of 8 and 4. So set it up, fraction equal fraction, x goes in the geometric mean spot, and I have my 8 and my 4. So what I find is x squared equals 32. So x is going to equal radical 32. Okay, so I have to simplify that. So let's try this. If I divide that in half, because I see it's an even number, I get 16 times 2. Okay, well 16 is 4 times 4. That's a double. That comes out. So x will equal, the single 4 comes out, 4 root 2, and that's my final answer. All right, so once again, go back through those. If you have any worries about where you position your unknown and your other given numbers in these kind of non-triangle connected geometric mean problems. Okay, let's go on to the next page and we'll start special right triangles. So before I start special triangles, I'm going to do a little quick setup for you. So we're going to ignore this for right now, and let's do the following. If I have a 45-45 triangle, I know it. If I have two equal angles here, they have to be 45-45, or perhaps they'll actually put the 45 in there. Either way, I have to recognize that that is a 45-45-90 triangle. There's a certain relationship between the sides in this special triangle. Okay, so we said again, these are 45. You have no option. They have to both be equal because of the notation, and you have to have 180 degrees in a triangle. So the relationship between the sides is as follows. Each leg will be exactly the same. We're going to call that A. The hypotenuse, which is bigger than the leg, is going to be A root 2. Okay? You want to memorize that pattern because that pattern is your key to success. Then we have one other special right triangle. That is a 30-60-90 triangle. Now they may just give you one angle, say they give you the 30, then you have to know the other one's going to be 60 because, again, you have 180 degrees in a triangle. Okay, with this kind of special triangle, there's also a relationship between the sides. Now the legs are not equal at this point, but the leg opposite the 30, we're going to call that our A. Opposite the 60 will be whatever that A is, opposite the 30, times root 3. And opposite the 90 will always be 2A. So that is the key to solving special right triangles. So again, you want to memorize that pattern. Okay, so I'm going to leave that up as long as I can. When it starts to interfere with what I'm doing, I will erase that. Okay, let's start the first problem, number 9. So that is a 60-30-90 triangle. So if you want to put the 30 in here, I think that's not a bad idea, just to really reinforce it with yourself. What are each of the angles? Okay, so this is what I'm going to tell you about this. The angle opposite the 30 will be equal to A. The side opposite the 30. The side opposite the 60 is going to be A root 3, and the side opposite the 90 will be 2A. So then what I have been doing when I work with you on Zoom was I said, okay, let's find the relationship that's set up, and there it is. So what do I see? I see that A root 3 has to equal 3 root 3. In each of these problems, you need to find A. That's going to let you solve the other sides of the triangle. So get A by itself. A ends up equaling 3. Okay, so that means that I now know, since y has to equal A, y is going to be 3. Okay, one answer done. Then I have x. Since x has to equal 2a, x is going to equal 6. Problem done. Okay, so using the pattern that I first described when teaching this is essential. It's going to make your work so easy. It's going to make all these very doable for you. Okay, let's go on to number 10. So 10 is another 30, 60, 90 triangle. So look where the 30 is. The side opposite the 30 is your A. The side opposite the 60 is your A root 3. The side opposite the 90 is your 2A. Okay, next thing we're going to do is we're going to look for a relationship. Okay, this one has a value. So I say 2A equals 3 root 6 over 2. My goal is always to find the A. Divide both sides by 2. Look what I'm going to do. I'm going to write divided by 2. Because we don't really divide fractions, you multiply by the reciprocal. So to get that division, I'm going to take what I originally had, change this operation to multiplication, and change that fraction, or change that 2 into its 1/2, which is its reciprocal function. Okay, so do your multiplication, multiply straight across, and I am getting A equals 3 root 6 over 4. Okay, so, at this point I'm going to start erasing things. So let me get rid of this so I have some room to work. So what I have now found is that since my y was equal to A, I now know that y equals 3 root 6 over 4. Okay? The other letter that's missing is the x. So look at your x and see how it has to equal A times root 3. Okay, so my x is going to be, write down your A, which we said was 3 root 6 over 4, and multiply that by root 3. Okay, so this is going to get a little complicated, but then it's going to be fine. Okay, so I'm going to do that multiplication. Remember that you can multiply under the radical. So that becomes 16. Excuse me, that becomes 18. Let me get rid of that 6. Whoops, let me get rid of that 6. Okay, make that 18. Okay, and you still have it over 4. All right, so I'm going to get rid of this next one because now this is getting in my way. Now, you have to think about this. That 18 can be simplified. So x is going to equal 3 times, 18 is 9 times 2, but 9 is 3 times 3 times 2. Okay, that's still 18. Circle the 3, that's going to come out as a 3. Since you already have a 3 out there, you're going to multiply the two 3's together and get 9. You have a root 2 left inside, and you have a 4 on the bottom. And that is your answer for x, which goes right here. Okay? All right, so that was complicated in that you had to follow a couple of steps, but the steps themselves were not necessarily difficult. So keep yourself organized and give yourself plenty of place to write. Okay, so let's go on to number 11. So number 11 is another 30, 60, 90. Okay, those are usually the more challenging ones. So looking at that, I'm going to label my triangle. Opposite the 30 is going to be the A. Opposite the 60 is the A root 3. And opposite the 90 is going to be the 2A. Okay, look for your relationship. There it is. Okay, so now let's start working this out. So if I know that A root 3 is going to equal 6 root 3, get A by itself, because that's always going to be our goal. Okay, A will equal 6. So, next thing up, let's now find the letters that we need. Well, I know that Y has to equal A. Well, if I just found out that A was 6, then Y has to equal 6. Okay, what else am I looking for? I'm looking for X. Well, if X is supposed to be 2A, then 2 times 6 is 12, and I have solved for both missing values. Done. Okay, finally we come to an easier one. The 45, 45, 90 tend to be easier. Okay, so do the same thing we always do. Establish your relationship. Now remember, the relationship is different in a 45, 45, 90 triangle than it is in a 30, 60, 90. So opposite the 45 is your A. Opposite the 45 again is your A. And then you have A root 2. So look, here's your relationship. A has to equal 6. So therefore, Y is going to equal 6. And X is going to equal something similar. Put the 6 in the A spot and then bring down the root 2. And you are done. Okay, so you've got all the missing values on this page. Okay, there's more practice on the next page. Okay, so we're going to do these 4 problems. And at any point, you can stop this video and go away and think about other things and then come back to it. Because if you just let me drone on and on, you may not gain as much from the material as if you take a break. Okay, taking a break is important. Okay, so I'm going to keep going. So, question 13 is a 30, 60, 90. So the first thing I always do is establish the relationships. This is A. I'm just going to make it bigger because they used A and B also, so that's going to be a little bit confusing. I probably should have changed that for you, but we'll deal with it. Okay, across from the 60 is A root 3, and across from the 90 is 2A. Okay, so get your relationship. There it is. If 2A equals 14, then A must be 7. That's going to help me. Now, that's my A, not their A. Okay, so their A has to equal my A times root 3. My A was 7, so that side is going to be 7 root 3. And that's what their little A equals. Okay, their B side equaled my A. So therefore, their B is 7, and we are done. Okay, so now 14 is a 45, 45, 90. So you can either fill that in or you don't have to fill it in if you don't need to have that reinforcement. Either way is fine. I know that this is A, and this is A root 2. Okay, so here's my relationship. Right away, I now know that N has to equal the same value that the other leg equaled because it's an isosceles triangle. So that's done. Okay, m is going to equal the a that we had times another root 2. So look what happens when I do that. I'm going to have 5 root 2 times root 2. That means 5 times 2 over 2. These 2's can cancel, and you end up with 5 for your value for your m. Okay? And so we're good with that. Okay, so let's move on to 15. So 15 is a 30, 60, 90. And labeling, I have a opposite the 30. I have a root 3 opposite the 60. And I have 2a opposite the 90. So look for your relationship. There it is. So what do I know? I know that a root 3 is going to equal 12. So get your a by itself, because that's always going to be your goal. Now, once you divide by a radical 3, you can't leave it like that. You have to rationalize it, and this is the procedure for rationalizing. You take that radical 3, and you put it over another radical 3. The reason why you can do this, and we've discussed this, is that this is just a 1, and you can always multiply by 1. So we're not changing the number, we're changing how it looks. Okay, so at this point, you're going to multiply straight across. So when you do that, you get 12 root 3. Now, root 3 times root 3 is root 9, which is just 3. Okay, and then you can reduce this. Now, this 3 can go into 12 4 times. Never put a whole number into a radical. You can't do that, so we just are going to bring that along for the ride. And I have found that my a is 4 radical 3. Okay, so that means that my y value, which has to equal a, has to be 4 radical 3. My x value, which has to equal 2a, is going to be just 2 times that 4, okay? You don't multiply a whole number by a radical. So I have to only multiply whole numbers together. So the root 3 comes along, and the 4 gets multiplied by 2, and that gives me 8 radical 3 for an answer. Okay, we have one more to go on this page. Okay, so number 16, also 30, 60, 90. So label it. Label your relationships. Again, I have a little confusion with the A's and the B's, but we're just going to go with it. So I have an A. My A is opposite the 30. Opposite the 60 is my A root 3. And opposite the 90 is 2A. Here's your relationship. If 2A equals 10, then A must equal 5. Okay, since B had to equal my A, their B is 5. Okay, since their A had to equal my A, which is 5, times root 3, then that's what their A is, 5 root 3. And we've answered both of those questions. Okay, so we have a couple more to do on the next page, and then we're done. Okay, so 17. Looking at 17, 17 is a 30, 60, 90. So set up your relationships. Across from the 30 is your A. Across from the 60 is your A root 3. And don't forget, you've got to memorize these. Across from the 90 is your 2A. Okay, look for a relationship. There we have it. Okay, this is going to be a nice one to do. So A has to equal 4. Okay, done. Their Y has to equal my A, which was 4, times root 3, and that's done. Okay, their X has to equal 2 times my A, and my a was 4, so their x is therefore 8. All right, done. Moving on to 18. Another 30, 60, 90. Establish your relationships. Here's a. Here is across from the 90 is always going to be your 2a, and across from the 60 is your a root 3. So you can put this on a little index card for yourself so that you always can see it. Okay, so let's establish a relationship. There it is right there. So a has to equal 4 root 3 over 3. Okay, so that's my a. All right, confusing again. Their a has to equal 2 times my a, so 2 times 4 root 3 over 3 is 8 root 3 over 3. Remember, don't multiply inside that radical with that whole number too. Okay, so their b has to be my a, which is 4 root 3 over 3 times a root 3. Okay, so we have to clean this up. So 4 root 3 times root 3 ends up being root 9, which is 3. Okay, the 3's can cancel, and b will just equal 4. Okay, so their a is a root 3 over 3, and their b is 4. Okay, we're winding down. Okay, this next one's going to be a 45-45. They're always a little bit easier. So establish your sides, a root 2, and there's my relationship. So a has to equal 10. If that's the case, then v, which had to equal my a, is also going to be 10, which makes sense because it has to be an isosceles triangle. And u, which has to be equal to a, and the a was 10, times the radical 2, and we're done. Don't do anything else with that. You are done. And look at you, you're down to the very last problem. Thank you for sticking with me. Okay, so opposite the 30 is a, opposite the 90, 2a, opposite the 60, a root 3. Look for your relationship. There it is. If 2a equals 18, then a must be 9. Okay, so their n, look at their n, needed to equal my a. So therefore their n equals 9. Their m had to equal my a, which was 9, times root 3, and we are done. Alright, so this is not necessarily easy to do, but you can absolutely do this. It just takes some practice and some stepwise procedures, and I hope I laid the good groundwork for that in this video.